It begins not with thunder, not with fire or screams or sirens. It begins with silence. Some nights, the world hums like a sleeping animal. The oceans breathe in slow tides. The forests sigh in the dark, and billions of people dream under the soft weight of the atmosphere. It is easy, in such moments, to believe the universe is calm, that nothing stirs beyond the blanket of the stars. But above that fragile ceiling of air, space is never truly still. It is a river without banks, a black ocean where continents of rock drift for eons, where the sun breathes storms of invisible fire, and where forces older than our planet itself continue their patient dance. Out there, every second, worlds are born and worlds are destroyed. And one night, not long ago, our own world came close, bearably close, to being one of the ones destroyed. It was the kind of night where cities glowed softly beneath the clouds, where street lamps made halos in the fog, and where somewhere, far away, a fox padded silently through snow. The vast majority of humankind was unaware that anything at all was different. We were watching films, tucking children into bed, sending last messages before sleep. We did not know, could not know, that in the invisible corridors above our heads, something was moving toward us. No sound, no streak of light, just a silent traveler, following a path that had been set long before humans could walk upright. It had no malice, no intention. It was simply obeying the laws of physics written into the bones of the cosmos. But intention or not, if it met us, if its path crossed ours in just the wrong way, everything would change. Earth is not as invincible as it feels beneath our feet. We live wrapped in a skin of gases, only a few dozen kilometers thick, a bubble of air and warmth clinging to a sphere of rock hurtling through the cold.
Oh.
All of history, all of art and science, every language and every song, they exist inside that shell, and shells can break.
Ass.
Nature has cracked it before. 66 million years ago, a fragment of space struck the peninsula with the energy of billions of atomic bombs. The dinosaurs never saw it coming. In the hours after impact, the skies burned, the seas rose in walls of water, and the air turned to poison. Life, in its great variety, was reduced to a desperate few survivors. That was not the only time. Human history carries whispers of fire in the sky, of nights turned to day by falling stars, of winters that lasted years because the heavens had cast down their stones. We tell these stories as myths. But space does not deal in myth. It deals in math. And the math does not promise safety. At 11:46 p.m., in one quiet observatory, a screen flickered with a faint speck of light. It was not unusual. Astronomers live in a sea of specks. But something about this one, something in the way it moved against the map of known stars, was different. Far from that observatory, another telescope, half a world away, recorded the same speck. The data, separated by thousands of kilometers but bound by the speed of light, would soon tell a story, a trajectory, a velocity, and a probability. The probability was not zero. Imagine an hourglass in which the grains are not sand, but seconds of your future. The clock had already been turned. The first grains had already fallen. With each passing moment, more slipped away. But no one outside a small circle of scientists knew. There were no breaking news banners, no emergency broadcasts, no hurried evacuations. The fox still padded through the snow. The city still glowed. The world still slept. If you are here now, listening in the calm of your own night, know this. You are listening to a story of how you survived a day you didn't know could be your last. It is a story of minds that kept watch when the rest of us dreamed. It is a story of equations scribbled in the dark, of radio waves racing across oceans, of human hands moving faster than fear. This is the quiet cosmos, and tonight we are going to drift together through the hours when our planet stood unknowingly at the edge of an ending, and the quiet science that pulled us back. So, find your most comfortable place. Let the hum of the universe be the only sound you notice. Because before the danger came, before the calculations began, there was just a whisper before midnight, and a speck of light in the dark. In the dark above the turning earth, an object moved invisible to the naked eye, unnoticed by anyone without the right instruments to see it. It was not the largest thing in the cosmos. It wasn't even the largest thing in its own orbit. But size is a deceptive measure of danger. The history of the universe is written in moments when something small, traveling fast, met something vast, moving slower, and neither was the same again. The speck of light recorded in that quiet observatory did not blaze across the screen like a comet in a painting. It was faint, almost reluctant to be noticed, but its path betrayed it. Stars are fixed, or appear to be in the background of a telescope's gaze. But this point of light shifted just slightly between frames. Against the deep map of the cosmos, that shift was enough to tell the astronomers, this is no star. More images were taken. Each frame was a time capsule, a frozen whisper of the object's location. When those points were connected, a line emerged, a line that curved toward the blue-white sphere of our home. They did the first calculations quietly. Even quietly, the numbers carried weight. It was an asteroid, a near-Earth object, to use the clinical term. Roughly the length of a football field, not large enough to crack the planet's crust or blanket the Earth in fire, but large enough to erase a city, perhaps more, depending on where it struck. If it hit the ocean, walls of water could radiate outward faster than ships could flee. If it struck land, the shockwave could flatten everything for kilometers, with glass shattering hundreds of kilometers away. If it landed in a populated area, the death toll would rise before the smoke had cleared. And the worst part was this: no one was entirely sure where it would fall. The orbit was still being refined, and in orbital mechanics, small uncertainties can blossom into vast possibilities. A deviation of a few thousand kilometers in space could mean the difference between harmlessly missing Earth, striking it dead on. We tend to imagine such events as cinematic, the sky blazing with fire, the Earth shaking in real time. But the reality is both stranger and more chilling. The asteroid's speed was measured in tens of kilometers per second. At that velocity, the atmosphere itself becomes a weapon. Air molecules, compressed and superheated in an instant, would glow brighter than the sun. A bow wave of plasma would precede the rock, tearing apart anything in its path before impact. The ground zero site would be unrecognizable. The shockwave would race outward faster than sound, crushing buildings into rubble. Fires would bloom from ruptured gas lines and electrical sparks. Dust and debris would rise into the sky, forming a temporary shroud that could dim the sunlight for days. And yet you could miss it entirely if you lived far enough away. The planet is vast. Disasters are uneven in their reach. The terrible truth is that such an event could kill millions, while billions might only read about it the next morning. The asteroid's path was not a straight line. Nothing in space moves in straight lines for long. Gravity bends all journeys, and in our solar system, sun's pull is only the most obvious of the invisible hands guiding an object's fate. The Earth, the Moon, even the slight tug of Jupiter all play their part. The scientists worked through the night, running simulations, each one a model of the solar system with this new intruder placed inside. Thousands of runs, each beginning with slightly different assumptions about its position and velocity, yielded a forest of possible futures. In some, the rock sailed past harmlessly, missing us by hundreds of thousands of kilometers. In others, it didn't. There is a cruel phase in planetary defense work known as the window of uncertainty. It is the period between detecting a threat and being able to say with confidence whether it will hit. During that time, there is nothing to do but refine the data to measure and measure again, hoping the error bars shrink in the right direction. For this asteroid, the window was agonizingly narrow. It had been discovered late, only weeks before its closest approach, and even a single cloudy night at a key observatory could rob the scientists of a critical data point. The universe doesn't pause for our convenience. And so, as the rest of the planet carried on in oblivion, a handful of people stared at numbers on screens. Knowing that every decimal place could change the story of the world, it might seem strange, even unforgivable, that the public was not warned immediately. But in truth, false alarms can be their own kind of disaster. Announced too early, and you risk panic, economic chaos, and a loss of credibility if the danger passes harmlessly. Wait too long, and you lose precious preparation time. In this case, the choice was to wait not from negligence, but from necessity. The early numbers could not tell whether the rock would miss us by half the distance to the Moon, or pass straight through our atmosphere. And so, in the quiet, the work continued. For centuries, the night sky was simply a backdrop, a thing of beauty and mystery, but not a threat. Now, we watch it with different eyes. We map every object that could come near us. We build catalogs, track their orbits, and give them names or numbers. But the sky is vast. There are millions of small worlds moving through it, and only a fraction are known. This asteroid had slipped through until now, not because our watch was lazy, but because our watch is still young. Space is full of surprises, and not all of them give us much warning. By dawn in the observatory's time zone, the data was already flowing through international channels. Astronomers in other countries were alerted. More telescopes pointed toward the intruder, gathering light from it, breaking that light into spectra to study its composition. It was stony, dense, old, a relic from the early solar system. It had been minding its own business for billions of years. But now, its business and ours had intersected. And the intersection point was still uncertain. There is a small, scattered network of people who keep watch over the heavens. Some work in mountain observatories where the air is thin and clear. Others sit in quiet rooms in cities, connected to telescopes hundreds or thousands of kilometers away. They speak to each other in the language of coordinates, magnitudes, and uncertainties, a language where a single number can change everything. Most of the time, their work is routine. They track known objects, refining their orbits. They scan regions of space where new ones might appear. Many nights pass without anything remarkable, but sometimes something appears that demands their full attention. On that night, it did. The first astronomer to notice the intruder was not looking for danger. She was part of a scheduled survey, one of the countless sweeps of the sky made each night. The faint speck appeared in her image, set almost as an afterthought. But she had done this long enough to know when a point of light did not belong. She marked it, I measured it. Compare it to the star catalog. It did not match anything listed. A second observer, halfway around the world, confirmed it hours later. The confirmation didn't bring relief, it brought urgency. 2 data points meant a path could be drawn, and the path curved toward Earth. From that moment, the work was passed along like a delicate glass sphere from observatory to data center. From software analyst to orbital mechanic, from quiet offices to international agencies, it is tempting to imagine a single genius solving the problem in isolation, but that is not how science defends the planet. This was a relay, not a sprint. Each person carried the information a little further, refining it, testing it, challenging it, till it could be trusted. The relay began in darkness and would continue without pause until the clock ran out. To be among the first to learn of a possible planetary threat is to carry a strange kind of loneliness. You must keep working while knowing what the numbers suggest. You must appear calm in meetings, answer questions precisely, and avoid words that could spark alarm too early. In those first hours, the small group of scientists carried that burden quietly. They did not yet know if the rock would hit, but they knew it could. And could is enough to make every number feel heavier. The instruments they used were not the vast, movie-like telescopes you might imagine. Some were modest by professional standards, digital eyes on sturdy mounts, automated to scan the sky in slow sweeps. But the power was not in the size of the telescope alone, it was in the network. Images from one hemisphere could be combined with those from another, filling gaps in the object's observed path. Computer models could churn through thousands of scenarios in minutes. Spectrographs could analyze the asteroid's reflected light, revealing its density and structure, critical for predicting the effects of any potential deflection attempt. And all of it happened quietly, without the world noticing. While the public slept or commuted or ate their dinners, an invisible thread of communication spanned the globe. Astronomers in South America sent updates to Europe. Europe relayed to Asia, Asia to North America. The sun never set on the work, the network's rotation kept the watch unbroken. There were no headlines yet, no phone calls to presidents, only scientists speaking to scientists, yet bound together by a common understanding. Every minute counted. The most remarkable thing about these people was not their knowledge, though that was deep and hard-earned. It was their calm, when most of us imagine an imminent threat to the planet. We picture chaos, racing footsteps, raised voices. But in the control rooms and data centers, the tone was measured, almost gentle. Numbers were checked, graphs were updated, simulations were rerun. It was not indifference, it was discipline. They could not afford panic, not in themselves, and not in the data. Most of their names will never be known to the public. If you pass them in the street, you would not guess they once held the fate of millions in their quiet hands. They will not appear on currency or in statues. Yet they are the reason we are here to tell this story. History remembers those who charge into battle with a sword. It rarely remembers those who, sitting in silence, calculated an orbit just in time as the hours passed. The asteroid's path became clearer, but not yet safe. The calculations still allowed for the worst. The next phase would require more than observation. It would require coordination at the highest levels. Decisions about what to prepare for, how soon to speak. But those decisions would rest on the work done here, in the quiet, by people whose only weapon was the truth and the numbers. They did not sleep. They did not look away from their screens. They kept the watch, because sometimes the greatest acts of courage are not the ones that rush into danger, but the ones that stand perfectly still, watching the sky. Time is the most ruthless force in the universe. It moves the same for everyone, but never at the same speed we feel it. For those who watched the asteroid, each second was both unbearably slow and gone too fast. By now, orbit models had been refined dozens of times. Each new observation was like adding another bead to a thread. The shape of the loop grew sharper, more precise. And what the shape suggested was troubling. The probabilities were still shifting, but the trend was wrong. The range of possible futures was narrowing, and to many of them ended at the same point, a collision. This was the moment when quiet calculations became urgent warnings. The asteroid was no longer just a possible threat, it was a probable one. It is one thing to imagine an asteroid hitting Earth. It is another to see the math that tells you exactly when and where the projected impact time, if it happened, was just over 2 weeks away. That is nothing a blink in the scale of space missions. Space agencies design asteroid deflection missions to take years, even decades. And now, the countdown had started at 14 days. There was no margin for a traditional solution. No long runway to build rockets from scratch. Okay, whatever was to be done would have to use what we already had here. Now, planetary defense has no single owner. The decision-making is scattered across a web of agencies, governments, and international partnerships. NASA's Planetary Defense Coordination Office, the European Space Agency's NEO program, the United Nations Office for Outer Space Affairs. This web can be slow to move, but when the clock is measured in days, slowness becomes dangerous. The alert was sent through official channels. Potential impact event response coordination required within hours. Secure conference calls were connecting people across continents, scientists, engineers, military liaisons, and political leaders. Each spoke their own language of priorities. Science talked of probabilities. Governments talked of logistics. Militaries talked of contingencies. While leaders spoke, the asteroid moved. It was not waiting for permission. Every minute without action meant the point of no return came closer. At this stage, even the smallest delay, a meeting postponed. A signature not given could mean the difference between intercept possible and too late to try. It is easy, in retrospect, to say decisions should have been instant. But in the moment, the weight of acting too soon on incomplete data is immense. Launch too early, and you could waste billions, or worse, send a spacecraft into the void with no target. Launch too late, and there would be no second chance. The physics of asteroid interception is cruel. The earlier you act, the less force you need to change its path. A gentle nudge years in advance can make a miss by millions of kilometers. But wait until the object is close, and you need a violent shove, something humanity is not always prepared to deliver. At 14 days, asteroid was already within what scientists call the late mitigation window. That meant the only hope was a high-speed intercept, a kinetic impactor smashing into the asteroid hard enough to change its course by a hair's breadth. A hair in space, however, can be thousands of kilometers on Earth. In rooms no cameras entered, the debates were, Sharp, but controlled. One side argued, "We must act now, before the path is fully confirmed." The other, "We cannot justify the risk and cost unless the impact." Probability passes a set threshold. Threshold, a word that sounds clinical, but in that moment, it was a gate that either opened to action or closed to fate. The deciding factor was not politics, but math. A fresh set of observations came in from an observatory in Chile. When those numbers were fed into the models, the probability of impact ticked above the threshold. The gate opened. The race truly began. The chosen strategy was fast and brutal. Take an existing spacecraft design, strip it of non-essential components, mount it on the fastest available launch vehicle. Aim not for where the asteroid was now, but where it would be a point in space it would pass through days before its closest approach to Earth, if the spacecraft could hit it. Even slightly altering its velocity, the asteroid might pass harmlessly. Behind us, instead of directly into us, it was not elegant. It was not certain, but it was possible. Outside those rooms, life on Earth went on untouched. Weddings were planned, exams were taken, meals were cooked. Billions had no idea that in a handful of buildings, men and women were working at a speed and focus few could imagine because they believed the entire future depended on it. They didn't have the luxury of thinking about success or failure, only about the next hour, the next task, the next number. Every time they checked the clock, they were not measuring the time until launch, they were measuring the time until the asteroid arrived. In those days, the skies seemed different to those who knew. Looking up was no longer an act of wonder, it was an act of calculation. Somewhere up there, a piece of ancient stone was falling toward us with silent intent, and for the first time in human history, we were not merely watching, we were racing it. There is something deeply human about looking at the impossible and then trying anyway. When the asteroid's path became undeniable, and the clock began its relentless countdown, the question was no longer if we could act, but how? And the answer would come from the quiet language of physics, engineering, and precision. On the surface, the plan sounded absurd. Take a machine built by human hands. Launch it into the void at unimaginable speed. Did an object moving tens of thousands of kilometers per hour. Do it on the first try? With no rehearsal, it was like trying to hit a bullet with another bullet, except both bullets were moving. The target bullet was hundreds of meters wide, spinning unpredictably, and the distance between them was measured in millions of kilometers. The only reason it was even thinkable was because of the science built over decades in laboratories, universities, and space missions that had nothing to do with this moment until now. The team's first act was to pull from humanity's archive of spaceflight knowledge. We had studied asteroids before missions like NASA's OSIRIS-REx and Japan's Hayabusa probes had visited them, mapped them, even brought back samples. We had tested the concept of impact before the DART mission, just a few years earlier, had deliberately smashed into the small asteroid Dimorphos, proving that a spacecraft could alter an asteroid's path. Those missions had been science experiments. This one was survival. The plan hinged on a principle as old as Newton's laws: momentum. Change the asteroid's velocity by even a fraction, say a few millimeters per second, and over the days before impact, that tiny change would grow into a misdistance of thousands of kilometers. But there was no room for overcomplication. Drilling into the rock to plant explosives, no cinematic nuclear devices. The asteroid's composition was unknown to porous, and an explosion would pass through it like smoke. Too solid, it might shatter into dangerous fragments. A kinetic impactor, a spacecraft designed to hit hard and fast, was the cleanest, quickest option. Normally, building a spacecraft is a years-long process. This time they had days. Engineers rated existing hardware, satellite components already tested in vacuum chambers, propulsion systems sitting in storage for other missions, guidance software from previous intercept tests. Every choice was dictated by one rule: if it's not flight ready, now it's too late. The spacecraft was stripped of anything not essential to navigation and impact. No science instruments, no armoring. Its entire mission was to find the asteroid and hit it at precisely the right angle. Hitting the asteroid would require navigation accuracy so fine that even the tiniest miscalculation could send the spacecraft harmlessly into empty space. The onboard system had to be autonomous, able to adjust its course without waiting for commands from Earth. Signals to and from the spacecraft would take minutes to travel. And in the final moments, there would be no time for human reaction, so the spacecraft would carry its own eyes' optical navigation cameras to lock onto the asteroid and steer itself in real time during the last approach, even the most perfect spacecraft would fail if launched at the wrong time. The asteroid's path and Earth's rotation created narrow launch windows, moments when the rocket could be fired, so that the spacecraft's trajectory and the asteroid's intersected. Miss a window, and the next one might be hours later, or never. Calculating these windows was an exercise in celestial geometry, predicting where to moving points in the solar system would meet in 3 dimensions. The margin for error was so small that some engineers compared it to threading a needle from across the ocean. The work was relentless. In clean rooms, technicians in protective suits bolted components together with the knowledge that every screw mattered. In offices, orbital mechanics checked and rechecked trajectories until the numbers blurred in their eyes. Software engineers fine-tuned algorithms that would decide the spacecraft's fate in its final seconds, and always the clock on the wall, not the one for their shift, but the one counting down to impact, ticked closer. There was no partial credit in this mission. If they hit the asteroid too softly, the change in velocity wouldn't be enough. If they hit it at the wrong angle, it could spin unpredictably, making its trajectory harder to predict. And if they missed entirely, there would be no time to try. Again, precision here wasn't about pride, it was about survival. In the end, the confidence came not from hope but from math, from the simulations run thousands of times over, with every variable they could think of. From the history of spaceflight, where we had already sent probes to planets, landed on comets, and navigated the gravitational pull of worlds billions of kilometers away. We had done harder things given time. The question was whether we could do this fast enough. By the time the plan was finalized, the spacecraft stood assembled in its launch bay, a machine that was part human invention, part gamble, part act of defiance against the void. Somewhere above our heads, the asteroid continued its silent approach. It did not know we existed. It did not know we were aiming for it. And yet, its future and ours was about to change. From space, the Earth looks invincible. A glowing marble wrapped in swirls of white and blue, steady in its path around the sun. It is only when you look closer, much closer, that you begin to see the truth. It is anything but invincible. Our atmosphere. The air that carries every breath we have ever taken is thinner than the skin of an apple compared to the size of the Earth. From orbit, it is just a faint haze, clinging to the curve of the planet, a rock the size of the one now racing toward us could tear through that haze as though it were nothing. No matter how much technology we build, we still live under a sky that cannot stop the largest stones. The universe might throw at us. It is humbling to realize that all of human history, every poem, every song, every idea has happened inside that fragile layer. It is not an impenetrable shield. It is a soap bubble in a storm. We treat the Earth as permanent because it is the only home we have ever known. Mountains feel eternal, oceans endless, continents fixed in place. But the planet itself has been struck, reshaped, and scarred many times before. There are craters older than our species, reminders that extinction is not a theoretical possibility, it is a natural part of life on a cosmic scale. The dinosaurs were not careless. They were simply in the wrong place, at the wrong time, when the sky delivered a fatal message in that context. Our cities and satellites are fragile castles, made of sand, built in the quiet hours between tides. Space is not empty. It is a shooting gallery. Every day, the Earth is struck by thousands of tiny meteoroids, most no larger than grains of sand. They burn up harmlessly, leaving nothing but fleeting streaks of light we call meteors. But sometimes, something larger comes along. The asteroid that passed within the Moon's orbit in 2019, the Chelyabinsk meteor in 2013, which shattered windows and injured over 1,000 people without ever touching the ground. And now, this one larger, faster, and far less forgiving it, is not that we are unlucky to be in danger, is that we are lucky such events are rare. Astronauts often describe a feeling called the overview effect. Looking down at Earth from orbit, they see no borders, no politics, no divisions, only a single living world, astonishingly small against the backdrop of space. During the days of the asteroid crisis, this perspective became more than poetry. It became policy. Scientists and engineers from rival nations found themselves working side by side, their only allegiance to the pale blue dot below them. For a brief moment, the lines on maps faded. The only us was Earth. There is a temptation to ignore threats we cannot control. It is easier to think about bills, deadlines, and tomorrow's weather than to imagine a wall of rock falling from the stars. But fragility does not mean hopelessness. In fact, it is the opposite. The more delicate something is, the more it demands care, and the more valuable it becomes. We study asteroids not because we expect to find one tomorrow, because someday, without warning, one will find us. And when that day comes, it will matter that we looked up and kept looking. Here's the strange gift of knowing how fragile our world is. It makes it more beautiful.
Ow.
If Earth were invulnerable, it might feel ordinary.
Ow.
But knowing that we are, balanced on a thin blue thread, surrounded by an ocean of darkness, makes every sunrise rare, every heartbeat miraculous. In that sense, the asteroid was not just a threat. It was a reminder that we are small, that we are temporary, and that we are capable of extraordinary things when we remember those truths. As the launch day approached, news of the asteroid began to seep into the public. More people began to look up, not in fear, but in awe. Children asked questions about space. Neighbors pointed out constellations to each other. Telescopes sold out in stores. It was as if the whole species, for one fleeting moment, shared the same thought. We live here, together. If the asteroid were to hit, the damage would not be measured only in destroyed cities or lost lives. It would be measured in lost possibilities, conversations never had, songs never written, discoveries never made. The fragility of our world is not just about the physics of stone and atmosphere. It is about the fragility of our story. It is a story worth protecting. The world did not sleep that night. From crowded city apartments to remote desert outposts, from the decks of ships at sea to the hum of research stations in Antarctica, people were awake, waiting for something they could not see, waiting for a sound that would never come, waiting for a number on a screen that would decide everything, somewhere above our heads. In the vast black between worlds, a small metal arrow was racing toward a stone that had been falling toward us for months. At mission control, the countdown clock was a quiet, steady pulse. No dramatic music, no flashing lights, just the faint sound of keyboards, the occasional murmur of a flight controller, and the steady breathing of people who had rehearsed every moment of this day except the outcome. They had done the math 1,000 times. The simulations agreed. If the spacecraft struck at the calculated angle and speed, the asteroid's path would bend just enough for Earth to slip through the space it would have occupied. Just enough in this case meant a deviation of a few thousand kilometers, born from a change in speed so small it could be measured in millimeters per second. The difference between destruction and safety was not a wall, but a whisper. The asteroid itself was invisible to the naked eye, even through most telescopes. It was just a faint point of light in the black, indistinguishable from the stars until you knew exactly where to look. The spacecraft, smaller still, was a ghost chasing a shadow. In its final hours, the navigation cameras locked onto the asteroid. Algorithms adjusted the trajectory in tiny bursts, nudging the craft into perfect alignment. There would be no second try. If it missed, the asteroid would keep coming, and the spacecraft would keep flying into the darkness irrelevant. As the spacecraft approached, the images streaming back to Earth sharpened. At first, the asteroid was just a shape. and it was a spinning world of its own ridges, shadows, craters as old as the solar system itself, and then static. The last image transmitted before impact showed the asteroid's surface just seconds away, rocks and shadows rushing upward. Then the feed went black. It wasn't a malfunction. It was the moment of contact, a final, deliberate silence. The impact had happened. But whether it had worked, whether the asteroid's path had shifted, could not be known instantly. It would take 3 minutes for the data from deep space radar to travel back to Earth. 3 minutes where no one could act. No one could change anything. 3 minutes where 7 billion people lived in the same suspended breath, in homes and cafes and control rooms. Eyes were fixed on clocks, hands were clasped in silent prayers, not necessarily to a god, but to the math, to the metal, to the people who had dared to aim a human-made spear at the heavens. When the data finally came in, it was not a cheer that erupted first. It was a whisper. One of the trajectory analysts spoke into the quiet. We have a shift. The asteroid's velocity had changed not by much, but by enough. Enough that, when it crossed Earth's orbit, the Earth would no longer be there. Seconds. Later, the room did cheer not the wild, chaotic joy of sports victories, but the deep, exhausted relief of people who have been carrying the weight of the world and can finally set it down days later. When the asteroid passed the point where Earth would have been, it slipped harmlessly into the void. No flash in the sky. No shockwave. No crater. Just nothing. And in that nothing was everything: the preservation of a species, the continuation of stories, the quiet persistence of life. It is difficult to point to a single moment and say, here, this is when humanity saved itself. But in this case, there was one. It was the instant a spacecraft no larger than a small car slammed into a mountain of rock and nudged it, just enough that all of us could keep breathing. We did not just survive that day. We learned something about ourselves, that our fragility does not make us powerless, that the vastness of space is not only a threat, but a frontier we can navigate, if we dare. The world moved on, as it always does. News cycles shifted. People returned to work. The asteroid's name faded from headlines. But for those who had watched every second, who had run every calculation, who had touched the spacecraft before it left the ground, the sky would never look quite the same again, because they had seen how close we came to losing it all, and how for one night we stood together under a single, shared sky and did not fall. In the weeks after the asteroid veered away, the world felt quieter. Not because the danger had passed that relief was immediate, but because the event had left a deep echo in our collective mind. It is not every day that humanity stands at the edge of an ending and then steps back. The sky above us was unchanged, but we were not. We had seen, more vividly than ever, how delicate our place in the universe truly is. A single rock, older than life itself, had come within a cosmic hair's breadth of ending the human story. But fragility, we learned, is not the same as weakness. A soap bubble is fragile, yet it can carry a rainbow. Our thin atmosphere, our narrow orbital path, these are vulnerabilities, yes. But they are also what make Earth a home. To recognize fragility is to recognize value. To value something is to protect it. When fear could have led to panic, science led us to precision. It was not faith alone that saved us, nor luck, though we will always be grateful for both, but a deliberate act of measurement, calculation, and action. The equations that guided that spacecraft were written decades before by scientists who never knew their work would one day aim a lifeline at an incoming asteroid. We learned that science is not just a set of answers. It is a compass in the dark, a way to find our path when the landscape is shifting and the stakes are life itself. During the crisis, nations with strained histories shared data. Rival agencies coordinated. Scientists spoke in a single language. Numbers, when the asteroid came into view, it did not care who lived under its shadow. And when we looked up at it, neither did we. The stars have no borders. In moments of existential threat, neither should we. It would be easy to think of the asteroid as a villain. In reality, it was simply following the path gravity had given it long before humans learned to walk. The universe is not out to destroy us, but neither will it bend to keep us safe. It is indifferent, vast, and unimaginably old. This is not a reason for despair. It is a reason for awe. Because despite that indifference, we are here small, temporary, yet capable of reaching across millions of kilometers to change the trajectory of a mountain flying through space. When news of the asteroid broke, fear was the first reaction. But slowly, quietly, wonder crept in alongside it. People looked up. They asked questions. They learned the names of constellations. Even in the face of danger, our curiosity remained. It reminded us that exploration is not a luxury, it is a survival trait. A species that stops wondering will eventually stop looking up. And a species that stops looking up will one day be caught off guard. Long after the spacecraft's wreckage became part of the asteroid's surface, long after the headlines faded, one truth remained. We can save ourselves, not from everything, not forever, but enough times, perhaps to give our story the space it needs to keep unfolding. Somewhere, perhaps centuries from now, another generation will face another cosmic visitor. When they do, they will look back at this day not to remember the fear, but the proof that it is possible to act and to succeed. The universe does not write history in books. It writes it in craters, in orbits, in the faint drift of a rock that almost was our undoing. The day the world almost ended is written now in the stars, a faint, altered line in an asteroid's path, invisible to the naked eye, but carved forever in the mathematics of motion, and we too are written into that story. There's a strange weight in imagining the worlds that never came to be, the one where the spacecraft missed, the one where the asteroid stayed on course, the one where, instead of quiet relief, the countdown ended with silence followed by sirens. In our reality, we had years of warning, barely enough, but enough. But in this other version, the discovery came late. A glitch in a satellite's camera delayed detection. By the time astronomers realized what was coming, the numbers said it plainly. We were out of time. The world spun on, as it always does, but now with a hidden timer overhead. Each sunrise was not just another day, it was one less day. In this shadowed reality, there was no spacecraft already under construction. No mission plan in a drawer marked for impact prevention. Theoretical papers existed, yes, but they were locked away in journals few had read, waiting for funding that never came. Nations argued over who should lead, who should pay, who should decide. Months passed. And in space, the asteroid kept falling. There is a morbid comfort in knowing that even at the very end, the sky would not have looked different to most people. The asteroid would have remained invisible to the naked eye until the final days. Only when it crossed the moon's orbit would it have become a dark moving point, first a curiosity, then a presence, then a terror. By then, there would have been nothing to send, nothing to launch, no equation that could alter its path in time. The science tells us what would happen. First, a streak of light brighter than the sun for a few seconds. Then a blast wave, racing outward faster than sound, flattening forests, cities, everything in its path. If it hit an ocean, walls of water would rise, swallowing coastlines on multiple continents. If it hit land, dust and smoke would billow high, enough to dim the sun for months, plunging the planet into a cold, hungry year. This is not fiction. These are the fingerprints we've seen in the fossil record, in the shattered layers of stone that mark the end of the dinosaurs. In this version of history, billions of voices would have been silenced in a single day. Songs never written, children never born, the delicate web of culture, memory, and hope torn apart in an afternoon. The quiet cosmos would have been quieter still, not with peace, but with absence. And yet that is not the world we live in. It remains a phantom, a possibility erased by preparation, by foresight, by people who believed in acting before the danger was visible to everyone. It exists now only as a caution, a shadow on the wall that reminds us how fragile preparation can be and how unforgiving space is when we are not ready. We do not prepare because we expect disaster every day. We prepare because the cost of not being ready is beyond imagining. The day the world almost ended was not just a story of saving ourselves. It was a reminder that the difference between survival and silence can be a single decision, made years before the threat appears. The night sky tonight looks the same as it did before the asteroid came. Constellations still rise and fall. The moon still pulls the tides. The stars still whisper their ancient light into our eyes. And yet, for those who know the story, that sky will never look the same again. In the days after the deflection, the world seemed softer. Headlines still flickered with politics, sports, and scandal, but under it all was the unspoken knowledge that we had faced something vast and survived. It is strange how survival can feel both monumental and invisible. The streets still bustled, the seasons still turned, and yet there was an added weight to every sunrise, as if each was a gift we had almost lost. We speak often of the past, of what our ancestors left us. But this moment reminded us of something else, the future we leave behind. We are not only heirs to the earth, we are its temporary stewards. Our job is not just to live in this moment, but to pass it on intact, alive, and filled with possibility. To those who will come after, some may wonder why it is worth preparing for dangers that might not arrive in our lifetimes. But the truth is, all of history is built on choices made for futures unseen. The builders of bridges may never meet those who cross them. The authors of great discoveries may never know the generations they inspire. And those who look up at the night sky and prepare for what it might send, our way may never see the danger their work prevents. But the absence of disaster is its own legacy. Looking up now, stars feel less like distant, unreachable lights, and more like milestones, markers of a journey we have only just begun. Somewhere out there will be other asteroids. Somewhere, there will be challenges we cannot yet imagine. But there will also be ships, instruments, and minds ready to meet them. We are not helpless in the face of the cosmos. We are part of it, and we are learning to shape our place within. It's so to you, the dreamer, the thinker, the listener in the quiet hours. Remember this: the future is not something that happens to us. It is something we build, moment by moment, choice by choice. Every question asked, every answer sought, every ounce of curiosity you keep alive, these are the seeds of tomorrow's survival. The day the world almost ended is behind us. Ahead lies the vast expanse of time and space, a future worth exploring, worth protecting, worth passing on. And so under the dark sky, we close our eyes, not in fear of what might come, but in quiet confidence that when it does, we will be ready. Thank you for spending this journey with the quiet cosmos. If this story has stirred your curiosity, your wonder, or even just your calm tonight, consider joining us again and letting your mind drift among the stars.